So today we are learning about binary. And so binary is all about showing numbers. So we're going to look at what is binary and why computers use binary, and also changing numbers from normal numbers to binary numbers. This is loads of different ways to show numbers. If you recognize this, what's this? Anyone? Dice. Dice, great. So we can show numbers like that on a dice, or in words, or in using your hand, or even in, what's this over here? Kanji, right? So we can do it in loads of different ways, but it's all the same number. It's the same number 5. Let's look at the next slide. In math class, which number do we use in math class? Which one? Anyone? Numbers, right? We write this. Why not this? Well, it's so long and so difficult to write. We choose the best way to show numbers for the situation. So in math class, this is really good. But when we're speaking or writing, maybe this is better. So let's look at the next slide. This is my scooter. This is real. So what's this? If you can see, we're all on 999. What happens if I go a little bit more? A little bit more. It's going to go zeros, right? 10,000. So we're going to go to 10,000 on here. So each number will carry over to the next place. And that's how these work, right? The first number moves to the next number, and the next number, and the next, and keeps going. So these are all base 10. If you think about this number, there's 10 choices. It could be 0, 1, 2, 3, all the way to 9. So let's look at one more slide and see, why do we normally use 10 digits? This is a WooClap question, so grab your iPad. Anyway, so if we look on here, we got loads of great ideas. Some people don't know, that's okay. Some people are saying it's easy to use, some people said hands and toes, right? Ashi no yubi, okay, what's that about? Same thing?
Oh no.
Great.
Oh no.
Someone said, oh no, I like it. Awesome. So let's move on now, look at a little bit of an idea of, I think everyone here can count in tens, right? So this number, 143. How are we counting it? Well, we've got 3 ones. How many tens? 4 tens. 1, 2, 3, 4. And 100. So that big one on the left. So we call this place value. Everything has a place. Is it here or here? In a different place, it has a different value. So if we move the numbers, it's a different number. It's not the same. So this is decimal place value. We can all do this. Let's keep going and learn a bit more. Other ways to do it. So what's this? What's this? Anyone? It's a 59 is the number 59 seconds. Yeah. So it's a clock, right? And when we count on a clock, it's different. We count up to 60 and then we go to an hour. Yeah, so this will go to 1 hour, 0 seconds. And this is a different base. Instead of base 10, this is base 60. So different numbers can have different bases. Let's keep going.
What is that?
Can you recognize any of these? Anyone? We've got numbers here, normal numbers.
1, 2, 3, 4, 5, 6, 7, 8, 9.
Oh, where are the slides going? So we can count different ways in different languages. I think, oh, let's have a look at some.
We have base 60, we have base 10, base 10, base 10, base 10, 10, 10, 10. Base 20.
Okay, so
That's
different
Maya
countries are counting in different bases. So some places count in 20, some in 60, and mostly in 10.